So we're starting to talk about congruent triangles now and congruent figures in general. So this talks about congruent and corresponding parts. And we say if two geometric figures have exactly the same angles and exactly the same sides, they're congruent. So we talk about this as it says corresponding parts. This is the keyword, corresponding. So it says two polygons are congruent if and only if their corresponding parts are congruent. We're going to talk below for a second about what are the corresponding angles and what are the corresponding sides and our corresponding statement for triangles. So here we have these corresponding angles. Look at the markings here. You see how A has 2 marks. The one over here with 2 marks is H with 2 marks. So angle A is congruent to angle H. Angle B, we got to look at our figure. Angle B has 1 mark. Over here in this triangle, angle J has 1 mark. So angle B is congruent to angle J. Angle C, look over here, it has 3 marks in the corner. Over here, angle K has 3 marks. So angle C is congruent to angle K. Then with the corresponding sides, we got to look at the markings on the sides again. So AB, side AB, has 1 mark on it. Which side over here has 1 mark? And here we're reading it from A to B. So A has 2 marks in the corner. B has 1 mark. So it's AB, which would be HJ is the corresponding side. We need to have the correct order for the letters as well as identifying the correct side. So here we're talking about side BC. So again, if we look at the corners, we look at the vertices, B has 1 mark, C has 3, so we're going from 1 to 3 along BC. So in this triangle, we're going from J to K, from 1 to 3 along that side. So segment BC is congruent to segment JK. Our final side is AC. You see how it's labeled as AC, not CA. So AC is from 2 marks to 3 marks. So along here would be HK would be the side that is congruent to AC. So AC is congruent to HK. Here, we now have our corresponding statement about the triangle as a whole. So we're talking about triangle ABC. We have to state the points, the vertices, in the same marked order for ABC as we do with our second triangle that is congruent to triangle ABC. So since it's A with 2 marks, H has 2 marks. So triangle ABC is triangle H. B has 1, J has 1, so HJ. And then our final one would have to be K, because C has 3 and K has 3. So it's triangle ABC is congruent to triangle HJK. This triangle mark is very important because remember before we've used 3 letters to represent both angles and planes. So we need to make sure we use our triangle symbol with our triangles. For these examples here, we are identifying all congruent corresponding parts. I am going to start with the sides because those are listed first. So here we have GE. GE is congruent to LJ. Look at the picture. These two are going to be the ones that are congruent. And then we have EF congruent to JK. And then finally, for our sides, we have GF congruent to LK. So for our angles, the easy one to identify is angle F is congruent to angle K. They're both right angles. All right angles are congruent to each other. So that's our easy one to identify. Then the slightly harder one is looking next, but I would kind of see where these match up along here. So we have G matching up with L is how we wrote our congruency statements for our sides. So we can use the same thing for the angles because they correspond. So angle G is congruent to angle L, and then our final one, we'd have angle E congruent to angle J. And our congruency statement for our triangle as a whole would be that triangle GFE is congruent to triangle LKJ. This triangle is a little bit easier than our last one and a little bit harder in some ways. So I think it's easier because we already have the angles marked. So let's just write our congruent statements for our angles. We have that angle A is congruent to angle D. That one's easy, right? Those are both on the outsides and marked with one mark. Then the next angles we're going to have to label with 3 letters. We haven't done this for a little bit, but we can do it right now. So we can say that angle A, B, C, this is angle A, B, C, that's this angle right here, is congruent to angle D, C, B. Is congruent to angle DCB. This part right here, these two are marked as congruent, but we have to write them in that same order. So we have 1 to 2 to 3, 1 to 2 to 3. Our final angles that are congruent are going to be, we will label them as angle ACB. So this is 1 to 3 to 2 marks in the corners, is congruent to angle DBC. So 1 to 3 to 2 in the vertices of the triangle. Then on our side markings, we can say AB is congruent to DC. Again, looking at the corners, A has 1 mark, B has 2, D has 1, C has 2. And there's 1 mark on the sides, so that's obviously helpful. Then we can say AC is congruent to DB. And finally, on this last one, we would say BC is congruent to CB. This is also kind of the reflexive property. Saying this here, there are no marks on this middle side, but since it's the same side in both triangles, it's going to be congruent to itself. So our final congruent statement for the triangle as a whole will be triangle ABC is congruent to triangle DCB. Because again, A has 1 mark, B has 2, C has 3. Here, D has 1 mark, C has 2 marks, B has 3 marks. All right, we are now going to use the properties of congruence to find our x and our y. So in this congruent statement, we say that ABC is congruent to triangle DEF. So angle A is 65, and angle D here is 2y minus 5. So we're going to actually solve for y first because x has a y in it, so we're going to solve for our y first. So angle A is 65, angle D is 2y minus 5. So we can say 65 equals 2y minus 5. We add 5 to both sides. We get 70 equals 2y. Divided by 5, y equals 35. So we have now found our y. I'm going to, with our congruent statement, we could say BC is congruent to EF, so their measures are equal. So we can say 90.6 equals 2x plus y, but we found y is 35 already, so we can plug in 35 for y. We would now subtract the 35, and we would get 90.6 minus 35 would get me 55.6 equals 2x. Divide by 2 on both sides, x equals 27.8. All right, thanks for watching, guys.